Welcome back. This is 8.3 part 2, and we're going to dive right into finding an interval with the calculator. So number 16, use the given information to construct a confidence interval. And that's the language we usually use, this word construct. So notice we're given an x equals 52 and equals 71. And so just to keep it fresh in your mind, we could find our p hat right away. P hat is x over n, which would be that 52 over 71 equals 0.7324. Partly doing that to see that we're going to see that on the calculator as well. We don't actually need to do that by hand. So to find the confidence interval quickly on the calculator, here we go. The stat button, over to tests, and then look for one prop z int. And it's super important that you choose the interval option, not the test option. So here it is, it's my letter A on my calculator. Call it up and I'll put in the numbers from the problem. There's my x, there's my n, confidence level as a decimal. Go to calculate and we get a familiar interval. And notice right there, the calculator gives us a p hat value. So if we needed that and didn't want to do it ourselves, we could get that there. And it also then reminds us of our sample size. And so just to also keep it fresh, we're going to write out the interpretation. And so here I've written it out for the interpretation. We are 97% confident that, and now we're going to always be talking about the population proportion. And this problem has no context, so we'll just say the population proportion, P, is between 0.618 and 0.846. And depending on the context, it might be that you want to change those into percents. So 61.8% and then 84.6%. It'll just depend on the question. And it mostly is your choice if you want to do that. So let's try a problem. Page 398, number 20. According to the U.S. Census Bureau, 43% of men who worked at home were college graduates. In a sample of 500 women who worked at home, 162 were college graduates. And if those numbers seem familiar, we did just work with them. So here's our sample, n is equal to 500. And out of that number, some portion of that, x, is 162. Okay, so if we're wanting to find a point estimate for the proportion of college graduates, in this section, our point estimate is p hat, which is our some number out of the total, x over n. So 162 out of 500. We did this already, and so the point estimate would be 0.324. And now construct a 98% confidence interval. I will encourage you to use your calculator. You can do these by hand if you really want to, but I'm going to encourage everyone. And so what we might do for work is write down that we recognize that we're going to use one prop z int for interval, and then tell me what you put into the calculator. X was equal to 162, n is equal to 500, and the C level as a decimal, the confidence level, 0.98. You'll put all that in there, and then the calculator gives this very quick interval. We'll do it a little bit higher so I get room to write my interpretation. So that I'll copy down the long numbers, 0.27531, comma 0.37269. All right, I'm going to pause, see if you can write out the interpretation. And it might be a little different from mine, but they should have the same essence. How'd you do? This is what I came up with for my interpretation. We are 98% confident that the proportion of all work-at-home women who are college grads is between 0.275 and 0.373. And for the purposes of the next question, next part, it might be useful to change those 2%. So 27.5% and 37.3%. I'm okay with either kind of number, and you'll just see what might be in the back of the book for any given problem. Okay, notice the rounding. Always be careful with your rounding. All right, part C. Based on the confidence interval, is it reasonable to believe that the proportion of college graduates among women who work at home is the same as the proportion of college graduates among men who work at home? Explain. All right, so finally we get to refer back to that beginning sentence, which I kind of ignored, that 43% of men who work at home were college graduates on this survey. So look at the women's range there and then the men's, and we got to say what we're seeing. So I find a picture is really useful. So I'm going to bring that 43% for men so that we can compare it to our number for women. I like drawing my number lines. So here we go. The interval that we got is from I'll go back to decimals, I guess, 0.275 and 0.373. And we believe that the proportion for all women is in here. All right, let's go get the men's proportion, 43%, and put it on our diagram. 43%, 0.43 as a decimal. Where does that lie in comparison to 0.275 and 0.373? I think it lies way out here to the right, 0.43 for the men. All right, so we've got this interval over here to the left between 0.275 and 0.373. There's the men. I would say that's significantly higher. All right, so how do we put something like that into words? I will say something like this. Notice that it's just, is the proportion the same? So it's not really saying anything about greater than or less than. So that's how I'm going to word my answer. So here's one option. I wrote, since P equals 0.43 for men, is not in the interval for women, it is not possible for the proportions to be equal. And this would be a great thing for us to discuss in our class time, is how to say these answers. I will just show you a quick way for a little notation thing that's kind of fun. I can write a P for women by putting a little label on the P. So that's talking about the proportion for all women. And I'm going to say that that's not equal to the proportion for all men. So you can kind of introduce some little notational things when you've got one letter P for men and the same letter P for women. We can put little labels on there to help tell them apart. Okay, I think we can fit another example in here and still keep the video from getting too long. So here's our next example, page 398, number 22. An internet service provider sampled 540 customers and found that 75 of them experienced an interruption in high-speed service during the previous month. So letter A, find a point estimate for the population proportion of all customers who experienced interruption. We don't know what happened with all the customers. We only have our sample. So our point estimate comes from our sample. It's the sample proportion. So again, that's going to be some part out of a total. In this case, that would be 75 out of our total of 540 sampled customers. And that comes out to about 0.139. And as always, I don't mind if you write those as percents. Okay. And then part B, construct a 90% confidence interval for the proportion of all customers who experienced an interruption. I'm just going to bring my two numbers down here. N was 540 and X was 75. I'm going to scroll up a little bit for these two parts. So a 90% confidence interval can be super fast. I'm going to go to one prop Z int plug in all the numbers. We've got our n and our x. Here's our confidence level, which is 0.9 as a decimal. And I got, as numbers, 0.11441 and 0.16337. Write that better. I hope you're all pausing the video and playing along, because that's the best way to learn, is to do it along with me. Okay. And so that's all great. You'll get some points for just doing that, but I'm more interested in making sure you know what is this number or what is this interval that you just got. So say it out loud. How are you going to start your interpretation? If you're shouting at the screen, we are 90% confident, then you're doing great. So I'm going to pause and write it down. How'd you do? This is what I wrote. We are 90% confident that the proportion of all customers who had an interruption is between 0.114 and 0.163. And I always mentally put those in percents. That's 11.4% and 16.3%. So I'm going to always want you to do that interpretation. We are 90% confident that, whatever. And then part C, this is where we take things a level further. And what can we further say, given now that we have this interval? So the company claims that no more than 10% of its customers experienced an interruption during the previous month. Does the confidence interval contradict this claim? And so these are always a little tricky with the wording. And does it contradict? Does it support? Does it do this or that? We have to just read each problem and try to figure out what they're asking. So no more than 10% is 10% or less. The maximum is 10%. So, and then here's our interval that we have to get on a number line. So I always try to draw the number line. So our numbers are going from 0.114, or maybe I'll do percents this time just to be different. So 11.4% and 16.3%. So this is where our sample says that the population proportion is here. So we think that P is here in this interval. We're pretty confident. And the claim of the company is saying it was 10% or less, no more than 10%. That's over here. 10% is down below, or less. So is P possibly less than 10%? I don't think so, not according to this graph. P is well above 10%. So our interval does contradict the claim. The claim is that, oh, only 10%, less than 10%, and that we're seeing over 11%, all the way up to 16%. So our interval, I'll pause to write it down. Okay, here's what I wrote. Our interval does contradict the claim because the interval is completely to the right of 10%. In other words, we're believing that P, the population proportion, must be at least 11.4%, maybe even bigger than that. All right, so that's part 2, and we have one last little bit to talk about with sample size. So I'll return with part 3.